Hey everyone, my name is Krasi. I'm CEO and co-founder of Quark VR, and we just got a question about why do we need 5G in VR. So I made a presentation about it. Hopefully we'll get to answer those questions, because the reason I'm doing this presentation is when I talk to people about VR, 5G, and edge cloud. Those are all abstract terms that sometimes people struggle to understand and how they tie in together. But it's actually about making VR more accessible to more people and cheaper. As Daniel said earlier, we today, in order to have a high-end VR experience, we need to buy this computer that costs, especially in Europe. Don't get me started on prices of technology in Europe, and PCs and laptops and VR including. So you have to make a big upfront investment, then you need to have a room in your home, etc., etc. And once you get to the experience, it's a great experience, but that's not the problem. The problem is getting to that experience. And before we start, let's do a little show of hands. Who here has developed for VR? Awesome. So you may be familiar with this picture. It's something that Oculus showcased at their Oculus Connect conference. It's the same app. It's called Dead and Buried. It's a game that is running on the Rift and on the Quest. And on the projector, and from where you're standing, maybe those two pictures look the same, so I'll tell you what the few differences are. So one difference is the one on the left is running on a PC, the one on the right is running on the Oculus Quest mobile headset. The one on the left has a thing called dynamic lighting, whereas the one on the right has something that's called baked lighting. And something that is very hard to see is that the environment on the right hand side is one picture. And so it's one big picture that's being rendered. And that makes it possible to run something that looks that pretty on a mobile device. The only problem is that it's very hard to create applications like that. And that's for the following reason. So if you just develop for, let's say, Unity on a PC, you can just grab assets from the Unity store, put a scene together, and make an interactive app. That doesn't work on a smartphone or a mobile device. On the other hand, on the PC, you can do very beautiful things today. You can do photorealistic lighting. I tried a demo of the NVIDIA holodeck where I was able to look at the building design, make changes, then shrink myself, go inside the building, interact with the lighting, interact with the sun, so I can see how my building looks like through different times of day, different times of year. I think it was it's an experience that can transform how architects work. The only problem is it was running on a small supercomputer. And so let's try and somehow I have some slides missing here. Okay. I'll go back and forth. So this is a little graph that compares one of the most powerful mobile GPUs versus an entry-level desktop GPU, and you can see it's a huge difference. It's over 600% in favor of the desktop. And what actually you have to deal with when you develop for mobile is you have to work with less memory, you need to have very simple geometry, and lighting doesn't really look realistic. So what can you do? one solution is to have something rendered on a PC locally and being streamed in a way that is handled by the Vive wireless adapter. That works fine, but it's for certain use cases, like in the enterprise, you still have to buy a PC, etc., etc. On the other hand, if you look at gaming, cloud gaming, something that's called cloud gaming, is getting more and more traction. These are services by three of the biggest corporations in the world. GeForce Now is by NVIDIA. Project Stream recently got announced by Google, and you can already, in North America, you can already try PlayStation Now. It works pretty well. I've tried a demo of GeForce Now. Also works pretty well. But this is for traditional PC gaming, which means Full HD 1080p resolution at 60 frames. So if we want to scale that to VR, it becomes challenging, just because VR has high resolution, high refresh rate. It requires more bandwidth to stream, so you cannot do it over traditional network connections. One possible solution that I've seen, I actually saw that in Munich last month at the GPU Technology Conference. There was a project by Nokia where they do something that is called 3 degrees of freedom streaming, where you have two spheres for each of your eyes, and they are being rendered on a server, and you can watch that on a Gear VR, and you get high fidelity content on a headset that is mobile. One problem with that approach is that this is, as I said, 3 degrees of freedom, which means you can't really move. And if you ever tried a great VR game or experience, or even especially the training simulation, it has to be interactive. So this is a limited use case, and we need to do better than that. And it turns out with Edge Cloud and 5G you can. These are some of the use cases that my company Quark is working on. So you have Edge Cloud server that is rendering content in real time, which means each frame is being rendered and is being streamed over a network. And that way you get a fully interactive experience, and there are several different ways that you can use that. The most logical one is just get a headset like the Vive Focus or the Oculus Quest, and you'll be completely wired. But there are other use cases as well. You can have like an older laptop and just buy a headset, something like the Vive or the Oculus, hook it up to the old laptop, and again do the heavy lifting. And I wanted to give a little bit of a background of 5G. I heard that most of you here have been at previous meetups. A lot of you are very familiar with 5G, but for the rest of us, there are some stats. In theory, you can get 20 gigabits per second over 5G, a massive amount of bandwidth. I would say much more than we need right now, but the more the better. And you can get also very low latency, which is very important for VR and AR, to have the low latency when you interact with the app. There are gonna be pretty much two frequency bands. The first on the top is similar to 4G in terms of the frequency. That's the type of 5G that we're gonna see first on the market, and the other one is gonna roll out after that. But it's gonna offer much bigger bandwidth and even lower latency. And these are just a few headlines that I pulled from the web. Pretty much what I want to say here is a lot of money is invested in 5G. especially from companies like DT. So 5G will happen, and we that are in the VR industry should use it because VR right now needs that extra push to become a mass market industry. There are also other very interesting innovations that are happening in computer graphics related to AI. So the other big driving factor of computer graphics in the next 5 to 10 years is going to be artificial intelligence. And this here is an example of NVIDIA technology where you train a supercomputer you train a neural net that's being run on the supercomputer that basically can take low-resolution images and upscale them perfectly. And with AI, that could work really, really well. And what that means is if you have a streaming service for pretty much anything, could be YouTube, could be VR, you can stream low-resolution photos, and then as client devices today are starting to have AI chips, you can execute that neural net and upscale the image, and it looks much better than traditional upscaling methods. And this is kind of where my company comes together. We try to bring in those components together. We try to deliver server-side or edge cloud rendering. We provide you with low latency streaming to a bunch of devices. We right now work with all of the HTC devices, but we're trying to be platform agnostic. VR, as I said, requires very low latency, so we've developed this technology that focuses on very low latency. There are some trade-offs. That means that we would require a little more bandwidth than a traditional video stream. Almost done. And this is where 5G comes into us, because it provides us both with low latency and higher bandwidth that makes our streaming possible. And this is why I'm happy to be here today to talk about this and hopefully work with raum and DT on further projects surrounding that. These are some stats about Quark VR. I won't bore you. If you're interested, just find me later. We can talk about it. Yeah, that's pretty much it. We're working with companies to get the infrastructure rolling, to get that optimizations both on the device side with HTC, with NVIDIA on the AI side that I talked about. A lot of exciting stuff is happening in the industry, and we really see those new and upcoming technologies like 5G and Edge really drive the industry forward. If you have any questions, feel free to contact us or just grab me after. And yeah, that's all. Thank you.
Okay, super. Thank you for the presentation. Has somebody a question? Nobody? Even Tim?
Yeah, actually, I have something. I wondered, because of the question that we had learned. Yes. Actually, I had something in my mind. I was not sure. It was not actually a question to you, but to the guy who had this question a bit earlier, to Daniel. Yeah, asking, but why is this actually 5G, and where is this 5G? I would actually like to ask him whether he understands why this relates to the technical possibilities and needs actually of 5G. And if this question is now answered here by Kazi.
Hopefully.
Maybe just knock with your head, or?
It is, to some extent, because you pointed out the edge capabilities. I think that's an important ingredient, isn't it? Since I asked that question before, I think you pointed out the 8 edge capabilities, which seem to be an important part of your concept, right? So I'm sure one could design a similar concept by applying local computing facilities and stuff, but of course it would be a different concept and probably
and simply very challenging from a technological standpoint. Technologies like traditional Wi-Fi, 4G, frankly, they have not been designed for that use case. It makes them a little less reliable. And let me point out that the VR that we have today is simply generation 1. We expect resolutions to be much higher, refresh rates should at least double. So there's going to be a lot of demand going forward.
Hey Rossi, how are you?
Hey Leo.
My
That's
question.
a setup.
I've been paid $20 to ask this question. You had a slide up there showing all the metrics of 5G performance. So the bandwidth, latency, 1 millisecond, very impressive. So those are all, I assume, either median or best case scenario numbers, but with any sort of like face-mounted computer, worst case scenario numbers are very important because you get uncomfortable if 90% of the performance is spot on, but 10% or 1% even is below standard. So what are the worst case scenario numbers, and what are the sort of robustness fallbacks?
Right, that's a great question. And in full honesty, those numbers are mostly lab tests and the standard itself. It will take us a while to get there. It will take the industry a while. But we had a big discussion today here about this, and pretty much 5G is going to roll out in Germany in particular by 2022 with, I guess, a very big percentage of coverage. And it is up to us and DT and other partners to, if there's a use case for this, which we clearly think there is, the infrastructure could be built to support it in a good enough manner. Let's say for VR, you don't have to. As you know very well, each frame has to be presented within 20 milliseconds. And I mentioned that there's a lot of investments being made in the 5G field, so those requirements will be met. Yeah, Tim can add.
Maybe just adding a comment here, because I think this is not just a question referring to you. This is something actually you can actually also ask DT. And let me look around. So, this guy here, he's the Senior Vice President 5G of DT. Yeah, you can grab him. I don't know if he can answer the question. It's quite complicated. We got some more, I don't know, who else do we have here? Where are our 5G guys? Where's Carsten? Where's Richard? I don't see them. Alright, but we got some people here. Grab them maybe a bit later because we are, I think, a bit short already in time, and then have a talk on it. Yeah. Okay?
Thank you.
Thank you.
All right, thank you.